It's a 5. Might as well. Can we make this go away? Yes. Wonderful.
Thanks for coming out, you guys. Welcome to lecture 9. We're going to be talking about PID control and HC05.
Yes. So, and also a little bit about something called a processing IDE, which you're gonna get to use Java, which is fun.
All right. So PID control, what is that? Essentially, when we design a system, the main thing that we're trying to ask ourselves is how do we get the system do what we actually want it to do? So if you guys are at all interested in control engineering or control systems engineering, this is basically what they do, is answering this it sounds like a very simple question of how do we control a system? And so I'm going to walk you guys through the basic steps of what a simple control system is so that you guys can get a better understanding of how we actually use controls in order to make a system do what we want it to. So imagine we have a scenario where we built this car and we want it to follow an object. Let's say R is going to be our input. It's going to be like a book in front of the sensor or even a hand in front of the sensor. So when we put our hand in front of the sensor, we're going to enter right here into the system, which is essentially the beginning of the system. And this is, again, our R is going to be our hand in front of the sensor. Then the next step is our input is going to be going through this controller. And right now, because we don't have any previous information to do anything, this controller is actually not going to have any function right now. So then it goes to the plant. And this plant we can think of as a function that's going to do exactly what we want it to. In this particular scenario, our P of S is going to be some sort of function that measures how far away our hand is from the sensor, and then makes the motors move in order to move the car forward and backward. Now we've done something kind of similar to this with the distance sensor, in which we've measured the distance that an object is from our sensors, and then output something like an LED brightness. And so that's what our plant PFS is going to do. And then we come to here, which is Y, and we'll say that this is our output. And essentially what happens here is our car is going to start to follow or even recognize that our hand is in front of the sensor and start to try and follow it. However, the issue here is that regardless of how well fleshed out your function is or how well fleshed out your entire system is, you're always going to have some sort of issue with it, whether it be noise or error. So in this particular case, I'm sure a lot of you guys came into a lot of issues with noise calibration because your sensors either weren't working properly or you didn't calibrate it properly. So now it wasn't actually measuring the distance that an object was from the sensor. And so this is where we run into an issue and why we actually need controls in order to make sure that our system is going to do exactly what we want it to. So let's say we have some noise right here. For some reason, our car recognizes the hand, but it's not moving backward and forwards. It's kind of doing some other random things that we don't like. And so then that's where this feedback loop system comes into play here. And this is incredibly important because as opposed to just taking our output and just doing whatever it does, we're going to take our output and actually feed it back into the system. So now the second time we go around this entire loop, not only are we going to have our input, our hand in front of the sensor, we're also going to have some previous information. And this information is what the controller is going to use in order to make sure that our output is actually doing exactly what we want. So that's a high-level understanding of what control systems is and what a controller does. And now we are actually going to look at one of the most common controllers, which is the PID controller. It stands for proportional integral derivative. How many of you guys have taken EC? Possibly you guys?
Yeah,
we're in the class. Or you guys are in EC. Okay. I will have you know that Ops started the far following whatever project and then EC took it. So you guys, that's a little bit of tea. But anyways, so proportional integral controllers or proportional integral derivatives is the most commonly used controller because it reduces oscillation when it's correcting the system. And this is the general formula that you use for it. We'll be going over what each of the different portions of this controller does and why we use them and how you can actually implement this in your field. So first off, we have the proportional controller. And this is essentially just a constant value, we refer to it as a KP value, that's multiplied by the error. In our particular project, when we're designing a car, we're actually, the KP controller is going to measure the position. So when our car is to left of the line or to right of the line, our proportional controller is going to adjust for that. The issue with this, however, is because we're multiplying by a constant value, it's never going to change depending on the situation. In fact, even if we're here on the line or we're all the way out here on the line, your proportional controller is going to do the exact same thing. And so therefore, it's not variable and it's not flexible whenever we have increasing amounts of error. So a couple of important things to understand is that the bigger the KP value, the bigger the overshoot. And this just means that there's a lot of oscillation and a lot of time in order for your system to correct itself. And that's not something that we want. So that's a really great example of what KP does. You can see that when KP is really large, you're seeing the blue dot oscillate really far back and forth between the line. And our purpose is to try and bring our controller system all the way to zero as fast as we can. There's also a graph here that kind of gives you a really good idea of what the different KP values can do for your system. But the main thing that you want to remember is that KP is for adjusting the position. However, we do have to adjust our KP value in order for it to be really effective, which is where the derivative controller comes into play. The derivative controller is based on a change in error, i.e. you take a derivative. We also multiply it by some KD constant value, but the main thing is that we're taking previous information and feeding it back into the system. That way, your system can actually predict what's going on in the future. So the bigger the KD value, the longer it takes for your system to reach its target. And essentially, what we're looking for is a critically damped system. Can anyone guess what a critically damped system is? Or have you ever heard of it? Yeah.
No oscillations.
Exactly. So you are essentially trying to bring your error all the way to zero as fast as you can. Yes.
Same thing.
Okay, awesome, nice. Okay, so there's another really great graphic about what different KP and KD values working together can do. And then here's also another example of the different KP values, KD values and what they do to your system. The last thing that we have is the integral controller. And this accounts for the accumulated error by finding the error over a large amount of time. And this is obviously it's trying its best to bring the error down to zero. The KI controller essentially helps with overall stability. You won't really have to understand the nuances of that. However, it's really important to implement this within your controller and within your capstone project. Otherwise, you're going to have a lot of oscillations and your system sometimes will do things that are really weak. All right, so in terms of implementing a PID controller, a couple of helpful functions, or mainly the first one is millis, which essentially returns the amount of time that's elapsed since the restart button has been pressed. So this can actually be really helpful when you're trying to take the integral because it gives you the amount of time that has elapsed, and that's really important for the integration. Now, when we're actually trying to implement this U of T function, there are a couple of things. So first off, we have Ki, and again, this is the integral controller. And in order to implement this on our Arduino, we're just going to do int error is the summation of the time elapsed times the current error. And then for the derivative controller, we're going to do the derivative error is equal to the current error minus the previous error over the time elapsed. Question, how are you going to measure the time elapsed in the system?
Constantly. I mean, you should have like a constant time elapsed, and the previous error is like that, just like maybe like 5 ticks ago or whatever, like 5 blocks ago.
So we're actually going to use the same time elapsed in the integral, which is the millis. But yeah.
So it's the full one?
Yeah, you're going to want to do it. All right. Yeah, so this is a very base level approximation of what a derivative and integral is. However, for our system, it works well enough that we don't really have to worry about it too much. All right, so in summary, when we have any sort of system, we're always going to run into some sort of error, regardless of how well fleshed out their system is, whether it be through noise or other issues like your motor isn't working 100%, and so you have to account for that somehow. In order to do that, we need to read in values, and then from these values, we need to make adjustments in order to bring the error as close to zero as fast as possible. A couple of tips here. This is going to take a lot of just trial and error, tweaking your KP, KI, and KD values. So don't get confused or frustrated. It's taking a while. However, on the spec, there's going to be like a range of good KP, KI, and KD values to try, and you just have to calibrate it to your specific part. Does anyone have any questions about PID controllers? You don't really have to have huge, like, high-level understanding of it. Just this is some theoretical knowledge.
So for the interval controller, are you taking the interval from 0 to that time or from like the last measurement to that?
From 0 to that time. So you want to measure the overall error that's been accumulating throughout this entire trial.
Okay. And now we're going to move on to something a little bit different, not really related directly to our like driving part of the capstone, but instead this is going to help us with our communication. Because when we have the capstone is like a self-driving car, right? That will like follow a wall or your hand. But if it's going to be driving, we can't just have it plugged into our laptop, right? And so we need a way to be able to control the car wirelessly. And that is what this module, the HCO5, is going to help us with. So HCO5 is a 6-pin Bluetooth module. We're only going to need the inner 4 pins, unless you're doing like some funky stuff. But we're mainly just going to use the middle 4. And the important thing to note is that this is going to use UART communication. So if you can recall, we went over UART a few lectures ago in our communications lecture. It was one of the communication protocols that Arduino uses. It's the one that it actually uses to upload code to the like when you upload code, you use UART too. So it's just like one of the most prevalent communication protocols that it uses. But the important thing to note about these HCO5s is that they are not cheap. These are expensive modules, and it's pretty easy to break them if you do the wrong thing. So just when you're doing your wiring, be very careful. Question?
I think HC5 really doesn't like Mac and white monkey.
Yeah, in the spec, we have a lot of different troubleshooting tips for Mac to get it to work. I don't know about M1 Max. We haven't been testing on that. So
I didn't have any issues with it.
You didn't have any
Yeah,
issues?
yeah. So you should be fine as long as you read through the troubleshooting things that.
I don't even know that.
Mhm. Yeah.
I guess that needs to work for me for a long time.
Yeah,
Oh,
there's
really?
stuff that we can do to fix it if it's not working. And worst case, we can maybe you can like partner up with somebody else who has a laptop and get it working.
It's finally working.
Okay.
Great. So a review of UART communication. It stands for Universal Asynchronous Receiver/Transmitter. And we use the Arduino serial library to communicate with UART. So that it also uses UART for the serial monitor. So when we're going to be using the HCO5 in our project, we're not going to be able to use the serial monitor because we're already going to be using the RX and TX pins, so they can't be used for both the serial monitor and for this. So yeah, that's also something to take in. And also, since it's asynchronous, remember that we need start and stop bits instead of a clock signal. And in the physical circuit itself, basically, when you're doing this communication, you want to, RX stands for like the receiving pin, and TX is the transmitting pin, so it's like output. So like they each have an RX and TX, and you want to send the TX to the opposite RX, and like the RX is receiving input from the opposite TX. That makes sense. And the ground, it has a common. And also you want to make sure that they're on the same baud rate, which is what you do serial lucky can 9600, you're setting the baud rate. So when we use UART with Arduino, we're going to want to use to transmit a value, we're going to want to use serial.write and then the value. which return, and then that's going to return the number of bytes written, just so you know that it was successful in writing them. And then also to receive bytes from the other one, we're going to use serial.read, which will return incoming serial data and it will return -1 at the end. So, an example.
Okay.
Fix the noise.
Just turn off and on.
The old classic IG trick. It's not working, turn it off. Back on. It works. It works like 90%.
Nice.
Okay. Let's hope that doesn't happen again. Let's hope this. Escape.
There's no escape.
Just go away. Okay, went away.
Okay.
We're good. Wonderful. Projectors hate us, guys. This is very unfortunate. So, as an example, first thing you're going to want to do, we make our global variable byte read, just a car, which is 1 byte value. And then we remember you are always going to need serial.begin. This is going to set up the baud rate, which we're also going to need to make sure you use the same baud rate on whatever device you're communicating with. And then in the void loop, and one thing we didn't talk about in the last slide is that you also want to use serial.available to check if data has been sent and before you actually do any reading. And then from there, you just say byte read equals serial.read, and that will read the byte from the read buffer, and then serial.write. Say if you wanted to just echo out exactly what you got, you could then put it back into byte read and echo it out, but you could also put anything in byte read that is a byte to write out.
Yeah, and serial.write, that's sending it back to whatever it just came from, like not
Yes.
serial monitor, right? That's just back.
Yeah, so that's if you have UART communication, you have like the RX and TX connected.
Sends it right back to the TX.
Yeah, so it will send it out through the Arduino's TX into whatever thing you just received it from.
Okay.
And then, like I said earlier, please be careful when you're working with this. So the main thing about HC05 when it comes to us is that it operates at 3.3 voltage for logic. And so Arduino, if you recall, will use 5 volts for logic. So if you send out high, it will send out 5 volts. That is not what this is expecting. This is expecting to receive 3.3 volts. And that's not for powering it. For actually, when we power it with VCC, if you see it says 3.6 volts to 6 volts. So it actually takes input for power. It will be fine to set it 5, but the logic level needs to be 3.3 volts. And what that means is that when you send it into the RX pin, when we send it from the Arduino, if we don't do anything, it will send into that RX pin 5 volts, which will short it and cause problems and break your thing. So don't do that. Instead, does anyone remember what we can do to drop the voltage down from 5 volts?
Resistor.
A resistor, yeah. And is there any combinations of resistors that are called something that we use in the past? Voltage
Yeah.
divider. Wonderful.
Because you can't just use a resistor because your receiver, it's not like it's starting at 5 volts and then you add in the resistor. I don't think it's going to drop it correctly.
And we also want to drop it exactly to around 3.3.
Yeah.
So it'll be nice to use it. So.
Right.
Does anybody have any questions about the HC05?
Could you just analog write 3.3 volts instead of 5?
Not exactly, because that the PWM sample signal that you're actually sending out is a little bit different than just getting photographic.
And in order to write to the receiver, you're using the serial.write function, and that's different from the analog write function. Yeah. Right.
So the next thing, now that we are able to use communication with our Arduino, UART communication with our Arduino from HCO5, we actually need something for our computer to use in order to set up a little front end, something that we can use to communicate, like on the computer side. So this is going to be not directly Arduino related, but it will allow us to communicate with our computer's Bluetooth to then send and receive signals to communicate with the Arduino, and it is called processing IDE. So it's an IDE that makes visual interfaces really easy to make. So you can make shapes, handle events, read/write reads, value from/to serial ports. And it's actually in Java, which you'll find that for our intents and purposes is actually really close to C programming. So you're really not going to have to worry too much about the Java part, and the like library pretty much does it all for you. The documentation, actually, so we have a link here, download/documentation. The documentation and reference is actually really good. You can just like go onto the reference page and then search up any function you want that they have. Like you're wondering like about mouse stuff, you can just type in mouse, and it'll show you all the functions that will relate to like receiving input about the mouse, or like position of the mouse on the screen. So I really recommend you check out the reference page if you want to look more into it. We also have some code for you in the Project 7 spec when that releases, which will also get you started. But let's get into it a little bit. So here are the like main functions that we're going to be using. So just like Arduino IDE, we have void setup, which is nice. It runs once, just like Arduino IDE. But instead of void loop, they use void draw, and that is going to do pretty much the same thing as void loop, which will just loop infinitely. And then some other functions that might be helpful is something like void mouse clicked, which runs only when the mouse is clicked, and it's going to be useful for reading like if we want to make like buttons in our interface so that we can press them. Like if we have our card and we want to say, okay, like go forward, we can make a button that says go forward or stop. You know, we want to be able to read when the mouse is clicking. Yeah.
Is that like, is it like a singular click or like?
So for this specific function is a singular click. Okay. So it's going to check for the down input and release input. There are other things you can do if you want to continue. And then if we just use size right here, we're going to want to put this function in setup, and this will actually create the window size. So if you're on like Mac or Windows, you know, like each thing has its own window, each program. So this will actually pop up its own window for us to use. And so that's going to set its width and height, like 900 pixels by 5,000 pixels if you use that. And here are some other functions. I'm not going to go over them in too much detail, but you can set the background color with RGB, 0 to 255 values, similar to actually what we did for our RGB LED, if you remember that. And then we also have fill, which is going to be the fill of shapes that we create, stroke, which is the color of the stroke around the shape, stroke weight, which is the size, and also create a rectangle, give it like the X coordinate, width, height, and then the radius, which is the corners to make it like curved. We can set the text size, and we can also write text. Yeah, that was big.
Oh,
I don't know.
okay.
What does it look like?
It's just loading.
It's also loading.
Oh,
Well, and I know.
okay. Yeah.
But not the
Go back.
so for the text, yeah, for the X y coordinate, is that from the top left or from like the bottom left?
Honestly, I don't know. You're gonna test it out. I want to say it will be. My best guess would be upper left, but if you go on the reference site, it will tell you exactly. You can just type in text, and it will show up the function and tell you exactly the details. Well, unfortunately,
All right.
if it doesn't end up working for you on the computer later, maybe that will be nice. That's pretty common. So
Okay.
too big of a deal. Does anybody else have any other questions about processing IDE? The spec will go over it in more details, but if you have any questions now.
We don't use our Arduino IDE at all.
No, so remember, we're gonna also use Arduino IDE for communicating with like the HCO5 sending data out to, and then this will then like be taking in that data and also sending it to the Arduino. So this is like how this is the code that we're writing that's gonna run on our computer versus the code that's running on our Arduino. It allows us to communicate back and forth. Make sense? Anybody else have any questions?
Sure, in this case, why would you want the Arduino to send it back to the HTTP?
So for instance, if we want to know the state that the Arduino is and make sure that it received the communication. So say if we have our autopiloting thing and we have, say like, we have like 4 directions it can go. It can go forward, back, left, or right. So we want to like, so we say we click like go forward, and then we want it to be able to send back like the fact that it got it and like whatever state it's currently in. So that way we can know what the Arduino thinks it is in, or just, I don't know, it might be helpful for any general situation to be able to receive input from the Arduino and send back to work.
It's good for debugging. Like
Oh, yeah.
before you've implemented anything, you want to make sure that your HC05 is setting the right things. All right, so now going into our actual project. So just so you know, we are going to be using the HC05 to communicate with our computer Bluetooth. Essentially, what you guys are going to do is design an interface using 3 buttons using the processing IDE, and you want to send and receive signals between your computer and your Nguyen. Essentially, what we want you to do is to make an interface where you can turn an LED off, dim it, and then also make it super bright. Any questions about that? Okay, and obviously this spec is going to go into a lot of detail about it, and we'll be hosting a work session to get you guys started on that. But unfortunately, our parts are really delayed right now. I'm sure some of you guys with the SMB soldering workshop, you know, we've had a lot of difficulty getting our parts for the capstone and also this project. But once those parts arrive, we'll update you guys and the spec will be released and you guys can get started on working on it. But in the meantime, we'll just have to wait, unfortunately.
Yeah, very sad.
Yeah, but that's pretty much it. That's all we have for today's lecture. Do you guys have any questions about anything? For sure. I'll definitely send that out.
Yeah, we'll send it out. So you can do that. You know, I think you should do your own research, but I think I think the mouse tool is helpful to have. Yeah.
You know like that?
Like this, like these.
Okay.
Right-handed.
Yeah.
What was on the chip?
It was just like it's GIF. It's not GIF. It's definitely
I
GIF.
said both.
It was just an example that I made using processing IDE, where I made something where you could click and it like made a circle wherever you clicked, just like a little simple thing to show you. It's not that big of a deal though. We have starter code that will walk you through it, so you're not missing anything.
Is it Java that different or than Java?
It's not very different. For the purposes that we're going to be using, it's pretty much identical. When it goes into like classes, there's some differences with like notation and like garbage collection. There's some differences, but in general, for our purposes at this low level, they're pretty much the same.
We basically code the exact same.
Yeah.
Okay.
Yeah, it has automatic garbage detection. It's very nice. It's very nice. We like Java. Minecraft is made in Java. Okay, well,
Does anyone have any questions? We're all good. Also, do you guys like, so we're trying to design merch right now for you guys. Do you guys like caps or t-shirts? What is your, yeah,
T-shirts.
t-shirts?
if we did get t-shirts, what would you want on the t-shirt?
Were there any ideas already?
We're probably, I mean, right now we're just thinking, we don't have too much money. So or we have enough money for it, but we also are thinking about doing other stuff with the money. So we would want to put maybe just like a little text on it. Not like we can't put like giant complicated prints, but maybe we were just thinking like the ops logo, like I don't know, on the front. That's a good question. I think if you go to this one, I think Brian made this logo right here. I don't know. Is this a good logo? Yes. I brought it up.
Oh, it's there.
Yes.
What was that?
We were also thinking about instead of doing t-shirts, doing like hats.
Yeah. Oh, no.
How expensive are the HC05?
They're like $8 a piece.
Expensive enough that we don't want you breaking them.
On AliExpress for $2. with free shipping. They do get here in
True,
they do get here in 4
unfortunately,
months.
the
so.
department is not, yeah, that won't be very helpful.
This will take somewhere between like 6 months to.
Yeah. And maybe if our ops lead buy them right now for next year.
It takes like 4 months. I buy lots of AliExpress.
It's like $9.
Okay, thanks everyone so much for coming.
With $1